Hello students, welcome back to Sri Vidhyalakshmi Metric Arts and School YouTube channel. We are discussing Unit 2, Current Electricity, and today we are going to discuss about electric power and electric energy and internal resistance of a cell. These are the two topics we are going to discuss today. This is about electric energy and electric power. You just imagine the battery is connected to the resistor. Imagine a circuit like this, where the battery is connected to a resistor, like this. Let the resistance be R. Okay, let the voltage be V here. The battery is connected to the resistor like this. Let this point be A. Let this point be A. Let this point be B. Let this point be C. Let this point be D. As soon as the battery is connected to the resistor, charges start to flow from A to B, because there will be some potential difference. Charges start to flow. When the charges are flowing across the battery, they gain energy from the battery. Okay. Then we can say that the power gained here, or when the charges are flowing from A to B and then from here C to D, they lose energy there because of collision. They lose energy. So there will be voltage drop. They lose energy there. And again, the charges will flow continuously in the circuit. As soon as the battery is connected to the resistor, the charges are flowing from A to B. While they are flowing through the battery, they gain energy from the battery. As the charges are gaining energy from the battery, there will be loss of energy in the battery. There will be decrease in the energy in the battery. And the charges are flowing continuously. When the charges are flowing across the resistor, there will be voltage drop. The charges lose energy due to collision. And then the charges will come here and then they will be continuously rotating. There will be flow of charges across the circuit. Okay. Now, how much power is gained here, or how much power is lost here can be calculated. Power. How much power is gained here? Power gained. We know that power equal to work done by time taken. Power is equal to work done by time taken. Work is nothing but energy. Here energy is gained. How much energy is gained with respect to time? That's power equal to, you can write that power is equal to W equal to V into dQ by dt. The charges flowing at time dt is taken as dQ. From the equation, W is equal to V into Q. W, the work done W is equal to energy. W is equal to U, that is equal to V into Q. Work done in moving a charge is stored as electrostatic potential energy. This we discussed in chapter 1, electrostatics. Work done in moving a charge is stored as electrostatic potential energy. From that we write W is equal to VQ. Actually here we are taking it as dQ by dt. I is equal to Q by T, isn't it? Current I is equal to Q by T. Then current I is equal to, here we are taking dQ by dt. Then power is equal to voltage into current. We can write that power dissipated or power energy gained is power equal to voltage into current. If you apply Ohm's law here, Ohm's law is V equal to I into R, isn't it? Ohm's law is V is equal to I into R. Steady current flowing through a wire is directly proportional to potential difference between two ends of the conductor when there is no change in temperature. When there is no change in temperature, there should be no change in temperature. Temperature should remain constant. because when there is change in temperature, we have seen that resistance changes because the resistivity changes. We have seen that, isn't it? Resistance and resistivity changes when there is change in temperature. So, Ohm's law is applicable at constant temperature, V equal to I into R. If this is substituted here, you see that the power can be written as, we have power equal to, actual formula is power equal to voltage into current, V equal to I into R. If that is substituted, instead of V, we substitute I into R. One more I is here. From this we can write that power equal to I square R. From this we can write that power equal to I square R. So, this is also another equation to calculate power. Power P equal to I square R. This is also another equation to calculate power. We have power equal to voltage into current and also power equal to I square R. Based on the data given, we have to choose the formula. Okay, and we have power P equal to voltage into current. Power P equal to voltage into current. Ohm's law is V equal to I into R. Ohm's law V equal to I into R. Current I is equal to V divided by R. Current I is equal to V divided by R. If this value of I is substituted here, then you get power equal to, we have this voltage into current, that is equal to V. Current I is equal to V divided by R, that is equal to, then power equal to V square divided by R. V square divided by R. This is also an equation to calculate power in a circuit. So, when you are asked to calculate power in a circuit, based on the data given, we have to choose the formula. Power equal to voltage into current, power equal to I square R, power equal to V square by R. Here, according to this equation, power equal to voltage into current, unit for potential difference is volt, unit for current is ampere. So, we can write here, for power unit, we can write here it is volt ampere, we can write it as unit. Here we have power equal to I square R, unit for current is ampere, unit for resistance is ohm. So, we can write here ampere square ohm as unit. Here we have power equal to V square by R, voltage square by ohm. So, here we can write voltage square by ohm as unit. But practical unit of power is what? W-A-T-T. Watt is the unit for power. W-A-T-T. Watt is the unit for power. If 1 ampere of current is flowing through here, between the 2 points where the potential difference is 1 voltage, then energy dissipated, or the power dissipated will be equal to 1 watt, or dissipated will be equal to 1 watt. W-A-T-T, watt is the unit for power. Now, let us discuss what is 1 kilowatt hour. 1 kilowatt hour is 1 kilowatt hour is commercial unit for electrical energy. 1 kilowatt hour. Kilowatt hour is the commercial unit for electrical energy. Whereas in our home, from the EB department, staff come and note down the reading, isn't it? They mention how much money we have to pay, how much power is consumed and how much we have to pay. They mention the card, isn't it? Even nowadays they send through message or mail. There, the EB department staff, they note down the reading. The reading is in kilowatt hour. It is not in watt, it is in kilowatt hour. Commercial unit for electrical energy is kilowatt hour. Kilo, this is equal to kilo. 1 kilo is 10 power 3, isn't it? 1 kilo is 10 power 3 watt hour. That's equal to 10 power 3, 1 kilo, 10 power 3, 1000. This is watt, 1000 watt, 1 hour. 1 hour equal to 3600 seconds. 1 hour equal to 3600 seconds. Power equal to what is unit for power? Power equal to work done by time taken. Power equal to work done by time taken. In this case, energy consumed in time. So in this case, we can use joule per second. Joule per second as unit. Joule per second. So this is equal to 1000. Instead of watt, we can write joule per second. Instead of watt, we can write joule per second. And this is 3600 seconds. 3600 seconds. Then we get 36 into, that is 36 into 10 power 5 joule. We get 36 into 10 power 5 joule. This can also be written as, 1 kilowatt hour can also be written as 3.6 into 10 power 6 joule. 3.6 into 10 power 6 joule. 1 kilowatt hour. 1 kilowatt hour equal to 36 into 10 power 5 joule. 1 kilowatt hour equal to 36 into 10 power 5 joule of energy. Okay, 1 kilowatt hour is commercial unit used in electricity department. Okay, our household power consumption is measured with kilowatt hour. Now let us discuss what is horsepower. Okay. Horsepower, you could have noticed when we buy some motor to draw water from sump, we use motor. Even in agriculture, farmers, when they buy motor, and then they value how much horsepower motor should be purchased, whether it is a 1 horsepower or 1.5 or 2 horsepower. So HP, that's what horsepower is there. Even you could have noticed in a car advertisement, even for the car engine also they mention horsepower, isn't it? Let us see what is horsepower. Horsepower, H-O-R-S-E, horsepower. Okay, generally it is taken as HP, horsepower. 1 horsepower is equal to 746 watt. What is WATT? What is the unit for power? 1 horsepower is equal to 746 watt. It's because in older days, hundreds of years back, people used horse. Imagine this is horse, and then rope will be tied there. Okay, from the ground, and then coal will be taken through this. Coal will be taken from this. There will be a pulley, and when the horse moves this side, then the coal bucket filled with coal will come up, isn't it? So horse were used to bring or lift coal from ground to some height. So this one, when the motor was found, when the motor was designed, when the motor was discovered, when the motor was designed, what is done that when the motor was found and they compared the work done between the motor and the horse, they mentioned that 1 horsepower equal to 746 watt, which is equal to, if a horse is lifting 250 kilogram of coal, when a horse is lifting 250 kilogram of coal, okay, for 1 foot in 1 second, 1 horsepower is equal to 746 watt, which is equal to work done by a horse in 1 second to lift 250 kilogram of coal for a distance of 1 foot. It is done in 1 second. So this work done will be equal to 1 horsepower, that is equal to 746 watt. This is also important, you should note down the value. In case of some electrical appliances like some bulb, you could have noticed that its values, just like the bulb which is here, you could notice that that value is mentioned, watt is mentioned. For example, this is also a box which contains a bulb. Okay, you see here it is mentioned 40 watts here. It is mentioned 40 watts. It is mentioned 40 watts here. 40 watts. This is 40 watts bulb. 40 watts power. It means that it consumes 40 watts of power, isn't it? 40 watts bulb. For household supply, in India, for household supply it is around between 220 and 230 voltage. It's around 220 voltage is the potential supplied by the electricity board. Okay, it varies from 220 to let us take it as 220 for calculation convenience. Potential difference V equal to 220 voltage. Power equal to 40 watts for the bulb. Power equal to 40 watts for the bulb. Then how much current the bulb will consume? How much current is required? Just apply this formula, power equal to voltage into current, power equal to voltage into current. Then current I is equal to P divided by V. So that's equal to power is 40. Power is 40 divided by this is 220 voltage divided by 220 voltage. 0 gets cancelled. Then that is equal to 4 divided by 22. Current I is equal to 4 divided by 22 ampere, which comes less than 2, isn't it? It will be around 0 point something, isn't it? It's very less, 40. It is less than 0.2. It is less than 0.2 amperes of current. 4 by 22 amperes of current is drawn by the bulb. And we have another bulb here. Just for example, this is also a box of the bulb. You could see that it is mentioned 36 watts. You could see that it is mentioned 36 watt is mentioned here. 36 watts. This bulb requires 36 watts of power. 36 watts of power. You can use the same formula. 36 watts. It requires 36 watts of power. Power equal to voltage into current. Power equal to voltage into current. This bulb requires 36 watt. 36 watt. Power equal to 36 watt. Voltage 220 voltage is the voltage supplied by electricity department. Then apply the formula, power equal to voltage into current. Then current I is equal to P divided by V. Power equal to 36. Power equal to 36 divided by voltage is 220. Voltage is 220. That's if you just cancel it, you are going to get 18 by 11. You are going to get 18 by 11. And 10 power 10, if it goes up, it's going to be 10 power minus 1. That's equal to 1 point something. You will get 1 point, and then 11, you have 7 there. Then if you divide, it's going to be something around 6. You will get something 1.6. You will get something around 600. You will get some 1.6. 1.6, and this 10 power minus 1 is there. 10 power minus 1 is there. Okay. Let us discuss it again. I will explain it again. You just imagine, Vijay sir, note பண்ணிக்கோங்க, கட் ஆயிடுச்சு அது. போர்டில் திடீர்னு கட் ஆயிடுச்சு. போர்டு இந்த எழுதலாம் போயிடுச்சு, எரேஸ் ஆச்சுன்னா தெரியல. ஆமாம், எக்ஸ்பிளைன் பண்ணும்போது நோட் பண்ணிக்கோ, இந்த இடத்துல எடிட் பண்ணணும். Students, you just look at this. This says it is 36 watt. This says it is 36 watt. This bulb works at 36 watts of power. 36 watt. Then we have power equal to power is equal to 36 watt. Power equal to 36 watt. And potential from the electricity board, what we draw is 220 voltage. V equal to 220 voltage. V is equal to 220 voltage. Apply the formula, power equal to voltage into current. Power equal to voltage into current. Then current I is equal to, we have, this is 36 divided by 220. 36 divided by 220. That's equal to 36 divided by 22 into 10 power 1. You take it. That's equal to 18 by 11. That's equal to 18 by 11 into 10 power minus 1. which is equal to 1 point, it's 11, 7 is there, so you get approximately 6. 1.6 into 10 power minus 1, then we get current I is equal to, this is 0.16 ampere, 0.16 ampere, 0.16 ampere. Then the current drawn by the bulb is 0.16 ampere, 0.16 ampere. You can find out the resistance also, What is the resistance of the bulb? Okay, Ohm's law V equal to I into R, Ohm's law V equal to I into R. Ohm's law V is equal to I into R. Resistance R is equal to V divided by I. Resistance R is equal to V divided by I. What is the voltage here? It is 220 voltage. It is 220 voltage divided by, we have 0.16 ampere, 0.16 ampere. That is equal to 220 divided by, you can take it as 16 into 10 power minus 2. 16 into 10 power minus 2. Okay, and you just bring it here, that's equal to, this is 20, if you cancel, it's going to be 11 by 8. It is going to be 11 by 8. And if you commit here 10 power 2, this is into 10 power 3, that comes to 10 power 3, can be written as, then the resistance of the bulb is equal to, you get it is 1 point, you are getting it as 1 point, it comes 5, it's 50, you will get around 1.4, isn't it? It comes around 4. 8, you have 3 here, then you get around 1.3, you will get around 1.3, isn't it? It's 11 by 8, therefore it is 1, 3 is there, then you get around 3, 3 8s are 27, yes, approximately you get 3. So it's 1.3 kilo ohm, 1.3 kilo ohm, so that is R equal to, you just take it as it is, kilo is, it is 1.3, kilo is 10 power 3, isn't it? Kilo is 10 power 3, so you can write as 1.3 into 1000, 1.3 into 1000, which is equal to 1300, 1300, 1300, then the resistance of the bulb is equal to 1300 ohm. Resistance of the bulb is 1300 ohm. So for a bulb, we can calculate how much current it can draw, the data given there, how much, what will be the resistance of the bulb, all that can be calculated. So electrical energy was the work done to draw the charge. Power is nothing but work done by time taken. So power is how much electrical energy is consumed with respect to time. That's what power. Power equal to voltage into current. Power is equal to voltage into current. Thereby applying Ohm's law, we can rewrite the equations in different forms. Unit for power is watt. Unit for power is watt. W-A-T-T. Unit for power is watt. W-A-T-T. That's the unit for power. Commercial unit for electrical energy. Commercial unit for electrical energy is kilowatt hour. 1 kilowatt hour equal to 36 into 10 power 5 joule. 36 into 10 power 5 joule. Okay. Students, thank you for watching our YouTube channel. And school YouTube channel regular parunga. If you like the channels, if you like the videos, please subscribe. Convey to your friends also to watch these videos. We hope these videos will help you to understand the concepts better. உங்களுக்கு எப்பெல்லாம் டைம் கிடைக்குதோ அப்பெல்லாம் நீங்கள் இந்த வீடியோஸ் பார்க்கலாம் இல்லையா, அது ஒரு பெரிய அட்வான்டேஜ். ஓகே, we hope our effort will help you to understand the concept better, and you will also score good marks in the board examination. Okay, thank you for watching our YouTube channel. Thank you.